In this video, we're looking at linear systems and circles. So we're looking at how we solve systems of equations, look at equations of circles in their two forms, writing an equation of a circle, and converting between the equations of a circle. So linear systems. Linear systems are when we have two or more equations and we're trying to solve them. It's a system of equations. Okay, there's a couple different solution types, right? Systems could have no solution, meaning they don't cross at all. They could have infinite solutions, meaning they cross all the time. Or we could have finite solutions, meaning there's a set number of solutions we could have. Generally speaking, we're looking at one or two solutions because we're looking at a linear equation and a quadratic. But if we went up in terms of went into a cubic or a quartic, which is to the power of 4, we could be looking at 3 or 4 solutions to our equations. Okay, your number of potential solutions is equal to the highest power of the variable. So if the highest power of x is x to the 10th, then you could potentially have up to 10 solutions to your system of equations. We won't get that complicated. Okay, there are a couple different ways of solving systems. The first we're familiar with already, and that's substitution. Okay, it's generally my preferred way because it is more often than not the least amount of math and the least amount of chances of making a mistake, at least for me personally. Okay, substitution is also a way I can make sure that a variable gets eliminated in the process. Okay, because that's the only way substitution is going to work, is if it actually eliminates something. Okay, and here are some steps for how you can perform substitution, but I think the best way to show you is going to be an example. Hopefully this should be pretty straightforward for most of you because we've been doing this pretty much the whole class at this point. So I'm going to solve that equation, the first equation, for y. So y is equal to 3x minus 15. Now that that's done, we do the substitution part. So we look at our second equation, we have 4x plus 5 times our y equation, 3x minus 15 equal to 1. So x is equal to 76 over 19. Which simplifies down to 4. Now that's solved for x, but generally speaking, we're looking for both values. So we plug x back into one of our equations. So let's do this one, 4 times 4. No, I don't want to do that one. We know that y is equal to 3x minus 15 from here. So y is equal to 3 times 4 minus 15. Y equals negative 3, so our solution is 4, negative 3. It's two linears crossing, so we're going to have one solution. So that's how substitution works. Here's one for you to try. The next method is elimination. Elimination is most often used when you have more than 2 equations. So when you're talking 3 or 4 equations that you're trying to eliminate. And if you recognize, and it's easy to get problems to set up for elimination, it can actually eliminate a lot of algebra. Okay, the downfall to this is that sometimes you do have to do a little bit of careful math and distributive property to get it set up right. And you have to make sure it's set up right to avoid making simple mistakes. So here's one, and let's take a look at it. So we have So when you're doing elimination, you want to ask yourself that you need to get your variables to be the same. Okay, so in this case, our x's are the same, so that's ideal. But subtraction is tricky to deal with. So what I'm going to do is you're going to set them up however you write your first equation. All the other equations need to be set up the same way. So I've got x first, so I'm going to write my x first. I've got my y second, so I'm going to do that. And then I've got my constant on the other side. Now, since I want to add them together and cancel out a variable, I'm going to multiply this through by -1. Okay, so what we're going to end up with is x minus 6y equals 14. Negative x minus 8y equals 14. And then we're going to add them. So x plus negative x gives me 0. Negative 6y, negative 8y gives me negative 14y. 14 plus 14 gives me 28. So then y is -2. And then you can plug it back in. So x is equal to 14 plus 6y. X is equal to 14 plus minus 12. X is equal to 2. So your solution is 2, -2. So that's elimination. Now I did by -1. Sometimes you have to look for greatest common factors and multiply by maybe 2, 3, 10, something to get them to match. So try this one. So here's another one a little bit more complex. So let's see. So we need to get them to match. We need to look for greatest common factors. So let's look. I know 5 and 2, greatest common factor is 10. So let's write down the first equation to get to 10. So I'm going to multiply everything through by 2. So I have -10x plus 8y equals 14. Remember, everything gets multiplied by 2. 2, and then this one is 5. And remember, I want to be able to add and have things cancel out. So I'm actually going to multiply through by -5. So I'm going to say positive 10x minus 35y equals 40. And then we're going to add. So negative 10x is 0. This is going to be -27y. This is going to be 54. So y is going to be equal to -2. Then again, we plug in -2 for y. So -5x plus 4 times -2 equals 7. So -5x equals 15. X equals -3. So -3, -2 is the solution to that system of equations. So here's another one for you to try. Now we're going to talk about circles. Okay. The formal definition of a circle is a locus of points equal distance from a center point. So what that means is if we take a center here and we say a point this far away, and then we say a point here, as long as this distance is the same, it's part of a circle. And we could keep plotting points until eventually there'd be so many points that they would connect. And that is how we get a circle. Now, a circle has two different forms. There's a standard form of a circle, which is this equation right here. X minus a squared plus y minus b squared equals r squared, where your center is a, b, and your radius is r. Okay. Please note that it does look like vertex form of a quadratic, and there is a very good reason for that. Your other form of a circle is what's called general form. I know the standard form, general form, dynamic kind of switches for circles, but they're kind of a unique beast. From general form, you can get center and radius out of these formulas. I don't recommend memorizing these. What I recommend is remembering how to complete the square, because to get from general form to standard form, it's just completing the square twice. So here's one we'll answer in class. Okay, so this is what I was talking about in terms of completing the square twice. So what you're going to do is we've got our equation over here. You're going to group your x's, so x squared plus 4x, and then you're going to complete the square. So this is where we're going to do the b over 2 squared, okay? So 4 over 2 is 2, 2 squared is 4, so plus 4 minus 4. Then we're going to do our y's, plus y squared plus 8y plus 8 over 2, so 8 divided by 2 squared is 16, and then what we add we have to take away, right? We can't change the problem, equals negative 4. This is a perfect square, and this is a perfect square. This factors into x plus 2 squared. This factors into y plus 4 squared. And then you've got negative 20 left over. So we're going to simplify this now. So we have x plus 2 squared plus y plus 4 squared equals, we're going to add 20 over to the other side and give us positive 16. So our center is at negative 2, negative 4 with a radius of 4. So that's the center and the radius from general form together. So in this video, we looked at solving systems of equations using our two methods, substitution, elimination. New material was looking at circles, general form, standard form. Hopefully we looked at how to write equations of a circle and how to convert between the two forms of a circle.